John. Next, we have Dr. John Sir himself, who's currently faculty in the Department of Ophthalmology of Sri Ramachandra Medical College, Chennai. He's a formerly glaucoma consultant at Little Flower Hospital, Angamali, and West End Eye Hospital, Cochin. He has presented in various state, national, and international conferences and has won awards for smartphone-based virtual reality perimetry, smartphone ophthalmic photography, and virtual reality in ophthalmology. He has published on innovations in ophthalmology, AI, 3D printing, smartphone, slit lamp photography, and so on. And he's currently into technology and gadgets and does programming too. Over to you, John, sir.
Thank you, Prasanna.
Thank you, John, for
Thank you, sir.
formulating this entire program. Thank you.
Special thanks to TNOA and Mohan Rajan sir for this session. It's really inspiring to many innovators that such a program is available and they can see the journey of all these innovations. I'll share a video about my latest innovation.
From the mind to the eye, designing and 3D printing novel glaucoma drainage devices. Dr. John Davis Akkara, Dr. Narayan Balakrishnan, and Dr. Anju Kuriakul.
The authors have no financial interest in this presentation.
My colleague, Dr. John Davis, and I are practicing glaucoma consultants, and in this video, we have attempted to make an innovative glaucoma drainage device which can help young ophthalmologists to practice implantation of this device and help in future implantation of glaucoma drainage devices in everyday practice. The implantation of these devices are also very expensive, and hence it deters young ophthalmologists from buying them, practicing them, and then using it in human eyes. So through this innovation, we have attempted to make an interesting glaucoma drainage device which has been 3D printed and hence has been used in animal eyes.
Hi, I am Dr. John Davis Akkara, glaucoma consultant at Sri Ramachandra Institute of Higher Education and Research. I used 3D computer-aided design and 3D printing to design and print the glaucoma valves that we are talking about. So I used a free software called FreeCAD and drew the design of the valve which I had in mind. That was the foot plate. And once I had drawn the design and finalized it, I took it to our 3D printing lab in campus and used the resin 3D printer to print the model. There are two types of easily available 3D printers. One is the resin 3D printer and the other is the plastic 3D printer, which uses spools of plastic. Once the 3D printed foot plate was printed, I removed it from the mold, cleaned it with isopropyl alcohol, and then kept it under UV light. And once that was done, the foot plate was ready to use. I used the tube from a Venflon to make the tube of the valve. Once the tube was cut, it was inserted into the hole of the foot plate. And so this is the foot plate and the valve mechanism, and that is the tube. If you look at the other side of the valve, there are 6 canals opening in 3 in each side. These allow the liquid to flow in from the tube. We then fixed a bow tie in a plastic container and did a conjunctival peritomy to insert the valve. The foot plate of the valve is carefully inserted under the conjunctiva. Make sure that the conjunctival opening is big enough to accommodate the foot plate. The foot plate is then anchored to the sclera by suturing through the 4 holes using vicryl sutures. The tube is then measured and trimmed with the scissors. Once this is done, the next step would be to implant the tube into the anterior chamber. We have to make a track using a needle, partial thickness through the sclera into the anterior chamber in case of a phakic eye, and into pars plana in case of a pseudophakic or aphakic eye. Next step is to insert the tube into the tunnel so that it reaches the anterior chamber. Once the tube is inside, we have to make sure that it does not touch the endothelium. These are some of the other valves that we 3D printed compared to the first valve, which was actually quite big.
The biggest one is the first GDD that we implanted in the surgical video. There is the small one with the tube, which is the latest design as of now, and there is also a medium sized one. This is a top and bottom view of the first valve that we designed. We can see the flow of fluorescein dye through all the 6 channels in the valve conduit. This is a medium sized valve, top and bottom view. This is a design for the smallest and newest model that we had designed. This has a raised area on the top through which the tube is inserted, and it has multiple channels which channel the liquid into the bottom. The plate itself has multiple holes to allow fluid pass through into the subconjunctival space. The fluid flow is as seen in this video. Hope this innovation with 3D printing inspires young surgeons to start doing glaucoma valve surgeries and also to design newer models of glaucoma drainage devices. Thank you.
No, no, the footplate looks a little big, no? What it showed.
Yes,
Yeah,
the first footplate was slightly on the bigger side,
Hmm.
but the other footplates are the same size as the Ahmed glaucoma valve.
Okay, okay.
So this is basically using the technology of resin-based SLA 3D printing to prototype various designs for valve. So when we look at 3D printing, the usual thing that we think about is the filament-based large size 3D printing. And that is what we have at Arvind Pondicherry. And that is where I was started on 3D printing. And now that resin 3D printing is quite cheap. The printer is 30,000 rupees. The resin you get in a bottle of 1 liter. I wanted to see what we could do with that. So this is one of the uses of resin-based 3D printing.
Fantastic.
Dr. John, this is basically, we cannot call them valved implants. There is no valve here. This is a glaucoma drainage device. That's all. There's
Yes,
non-valved valve. This is a non-valve devices for practice.
Yes, sir. I tried to make a valve mechanism, but it didn't work.
Yeah, the valve mechanism is completely different. We have membrane valves, ball valves, micro valve,
Yes.
valve valves. So the problem with the valves is sometimes the valve stops working. They don't
Yes.
open up at the desired pressure. Always open is better than always closed. This is a bit complicated, venturi valves and that. This is so that's what when you are presenting next time you have to remove that
Valve
model.
from it.
This is a open devices, non-valve devices.
Yes, sir.
John, last week I saw a young girl with this resin 3D printer at her home. Okay. She was making her own comb,
Jewelry,
for toys, jewelry, the comb, and now I think it's become like a play kit. No, I asked her, how did you get? She said it was a gift from her uncle. The 30,000 rupees, whatever gift, and
Yes,
now
sir.
she makes her own jewelry for the Barbie toys and the small combs and things like that. And it's good that we can use this innovatively for the wet lab practice. No, but as J.K. Reddy said, no, you can't call it as a valve. Somewhere you should have been using the word GDD or whatever for
Yes,
wet lab practice. But definitely it can be a trial. But one thing is, nobody was able to challenge Ahmed for almost 30 years now, right? Not even a single valve other than Ahmed glaucoma valve. All have been tubes.
I tried making a valve mechanism. I actually designed a valve mechanism in it, but it is not moving. It just gets stuck.
It's not easy, I'm saying.
Yes, sir.
You need a genius like Ahmed. No genius have come after that. And I'm sure John can be a genius like him, but still, valve is not that easy to be done inside, to the eye, to work in that unidirectionally. But anyway, this resin
Venkatesh, actually, that is a membrane valve, which Ahmad uses, membrane valve. There will be two slits like this. When the pressure increases, they separate and leak it. The problem is after some time, they don't open up. When the material becomes stiff, the silicon membrane, it becomes stiff, it doesn't open. That's the biggest challenge.
Yeah,
That's why
people have seen, even in unused ones, after several years, they have seen that what you're saying, it has been observed.
Have you tried creating artificial cornea?
I tried it, but it doesn't give a transparent this thing. It is very translucent. Even though it says transparent resin, I use a transparent resin. It gives a very translucent output. So I actually printed one for that also.
Venkatesh, the toys of the days are changing. We played with dough and plasticine. And these kids are playing. The days have changed. We used to play with dough and plasticine, you see. And sometimes not even that, just plain earth.
All the schools nowadays, they have an innovation lab, sir. They have these innovation labs.
Yes.
They have 3D printers. And I want to go back to school now.
No, Suvan, she was asking me, Uncle, what do you like? I said, why are you asking? You said, if you tell me what you like, I'll make and give you. I was like, what is this?
In fact, I have told
they are spoiled for choices.
My God.
Really magical, huh? Yeah.
Absolutely.
In fact, two of my MBBS students here, they got inspired when I told them about 3D printing, and they have designed another device. They have made a lacrimal punctal plug. And in fact, I encourage them to put it on Thingiverse, that is open source website where you can download things. So that is uploaded yesterday. In fact, you search for lacrimal punctal plug, you will find the one which my MBBS students have designed on an iPad. So I told them we can use laptop and mouse and draw it on the software, CAD software. They said it's there on iPad, and they just downloaded this software and drew it on the iPad with the stylus. So it's quite simple. And
this is on FreeCAD? On FreeCAD?
No, sir. There is some other free software on the iPad which is easier to use than FreeCAD.
Okay.
Many softwares are there.
Fantastic.
I would suggest tinkercad.com if you just want to get started.
I've done that. I've been on Tinkercad, yeah. You know what? Actually, after a certain age, we become a little plastic. So it's a little difficult for us to restart with certain things like 3D modeling and things like that. But yes, I would love to. But it's a little uphill task.
RK, sir?
Yeah, it's a good, John, it's a nice innovation. And one question, what material, John, this plate?
So this material is a UV fixated resin. And it is not biocompatible. So right now, what I'm doing is only prototypes. So in fact, I have this here. And they are not fit for human use. They're not fit for biological use, but you can use it as prototypes.
Okay. But still in the experimental stage, you know, you have not implanted anything.
I implanted only in cadaver eyes, sir.
Okay. Why 4 holes? You can have only 2 holes. 4 holes. It's very difficult to fix, posteriorly.
I just tried making different designs, sir. So I just made
one. That's fine, but 2 is more than enough. Because if you circle the plate with the 2 holes anteriorly, it won't move. So 4 means it's very difficult to posteriorly to fix it. Yes, that's what I feel, yeah.
Yes, sir. Right now, the use of this one would be to practice in the wet lab. Before actually doing surgery.
That's correct, yeah.
But you can also try out different designs.
And also, as pointed by Reddy and Venkatesh, no, this is not a valve. So you have to do a occlusion suture. You have to during at least
the tube, yes, sir.
A patient, no, you have to occlude the suture with like. Yeah.
So this 4 holes means there's a 4-point fixation, is it?
I have made multiple holes on the valves. For the different valves have different designs. So I was just trying out which one works better. In fact, I just wanted to test out the 3D printer. So I made a bunch of this. Box is full of of DDDs. Box is full of DDDs.
Fantastic.
Good.
Well done, John.
Thank you, sir.
As usual. Yeah, fantastic.